Welcome everyone guys, today we continue implementing our own custom Redis using .NET Core. Basically today we're going to implement the master series because in previous video we have already implemented our child. And basically let me revise our architecture. We've already implemented our partitions. Here we have our partitions, and basically what we need to do is just add one master service which will serve as a router for a particular partition. And basically what it should do, it should route particular key value to a particular partition based on hash code. Also, and for that purpose, it should implement the algorithm. It can determine the right partition for a particular key. Also, we're going to implement replication. What do I mean by replication? That there will be another set of same services, kinda another master, another 3 partitions. And since partitions should be in one virtual network, I mean that no other external service can call partitions instead of master. I mean the only one actor that can send requests to partitions is the master. Therefore, if we got request to our master, we determine the right partition, we send these values to right partition, we got response, and then we asynchronously replicate to another master. And after that, this master will decide particular partition. They should be the same in the same setup, and it also sends the same value for the same partitions and got the response. That's the way it should work now, and this is what we are going to implement in this video. Okay, basically let me explain what configuration do we need here. Basically I will use options pattern for configuration managing. Got master options object, and here first of all we need to decide whether this is master or slave replication actor. In case this master, it can send the requests to all other masters which are slaves. In our case this should be master, this is slave, and probably you've already got it. We can have many slaves from 1 to infinity, depends on your budget, but the only one master, and this master asynchronously replicates to all other slaves. And since for one particular master we should determine whether it is master or slave. Good. For sure, if it is master, we need to add configuration for slaves. It should be like, in our case, localhost. In Docker configuration, some kind of this, I don't know, I don't know, maybe this. And also we need to keep our children URLs as well, because this particular master should know what partitions does he have, and based on that knowledge it can decide how to determine between each of them. Okay, in our case it also should be something like that, but as I remember we had 02 URL. Yes, now we should create options file. Okay, now let me create the same folder structure in our project. Okay, now go to the controller. It should be named as master controller. Yes, for sure. Remove all unnecessary things here. Okay, that redundant HTTP GET. And now let me implement method by method. What do we need? First of all, we need the way to monitor all of our partitions. What do I mean by that? If you remember, in previous video we implemented this monitoring method for entries, which actually just gets all data inside entry and in some kind reflect the hash table inside the particular partition. And for the master, what do I want to implement here is just to send this kind of request to all the children and just combine the results and show information for all of children's, which is managed by this particular master. And for that purpose we need to create some kind of DTO. And as you remember, our bucket DTO shows the internal information for one single partition. And we need the DTO which will reflect the information about a lot of those partitions. And there we go. Okay, we have URL for child. And we have a list of this bucket DTO, which is our entries. Bucket DTO is show the one particular bucket and all entries inside it. And in that method we want to return this DTO. Okay, and this is the point where we should create our master service, which will manage all the things internally for master. Okay, the first method will be the add method, in which we should add particular value by particular key. And also we should, prior to that, we should determine what partition should handle this request. First of all, we need to determine our hash. And this is the place when the problem arrived, because in .NET Core, maybe you don't know, the hash code of string varies between the runs. For example, if I put something like that, get hash code, between different deploys and between different runs, it will generate different hash code. Therefore, we cannot use anymore native get hash code. And for that purpose, I need to use some kind of external library. Also, it should be like hash function that is not cryptographic hash function, because we need a good performance. And if it is cryptographic hash function, we'll be get big performance penalty, I suppose. I found such a library, Jenkins hash function. It is the algorithm for as non-cryptographic hash function. And also I found a good library which I start in Git, Jenkins hash function, Git .NET. By this NuGet package we can use our Jenkins method and Jenkins hash function. For this, for sure, we should put it in our implementations. Okay, here's the NuGet. This NuGet provides a pretty good interface. We'll use this interface for our algorithm. And in order to use this algorithm, it allows and it receives only a bytes. Therefore, we need to convert our object from the particular object. In our case, it will be string, but for future, I extended it to generic. We should convert it to JSON, as I told in the previous video. And then from JSON, from string, we should convert it to bytes. And in order to do that, let me create another service which is called our serializer, or kind of binary serializer. In our case, we'll put only one method here which returns bytes. Okay, first of all, we need to convert from the object to the string. Okay. Then, by using encoding, we just convert our string to bytes and return those bytes. Okay, now we can use this abstraction in our hash generator. Then we got hash from Jenkins algorithm, but also the hash is returned in bytes. But as I know from Wikipedia and from the description of the library, the hash is returned range of int 32 bits integer. Therefore, we should get 4 bytes because 4 times 8 is equal to 32, which is the length of our int, or sorry, not of our, but of the int which is returned by Jenkins algorithm. Yes, we can use asynchronous version, but it's not so important in our case. Yes, and in .NET we have already had a bit converter which can do and map those 4 bytes to the unsigned integer. When our function is ready, we also extract interface. Right, good. We should put it in our abstractions. Okay, now we go back to our master service and we should compute hash here, but for that purpose we should inject our Jenkins hash generator. This interface should be named as just iHash generator because we can put every implementation here. We should not be dependent on it. For example, if we decide to extend to dependency inversion and to put these implementations in other places, it's good to not be coupled to naming. In broad sense, it's not good to be coupled to naming of particular algorithm. We don't use interface in that case if we coupled by naming. Okay, and the same I can rename as a binary serializer. We also can use here an implementation which fits our needs. Okay, then let me inject this hash generator into our master service. Yes. We generate hash for our key. And the next step, we should somehow determine what partition should handle this particular hash. And as you remember, our partitions is partitioned by hash key, and each particular partition handle some kind range of hashes. Therefore, let me implement this determine child method. Also, we need our abstraction for a child. And we should initialize list of our childs with the following parameters. It should be pro-string child URL because we need to know where to send our HTTP request. We should know the lower bound of hashes and upper bound as well. Yes. And also, in order to determine the particular children, this method is immutable actually because it should be available for testing, and in my real project and in my Git, my Redis at Git, I added tests to this function because it's kind of our business logic. It's not like business logic, but it's valuable behavior for us. Okay. First of all, we should get hash mod by our overall count. What does it mean, this overall count? It is the all count of all nodes from all partitions. I mean, if we have two partitions, one partition ranges from 1 to 30 and the second partition from 31 to 60, the overall count will be 60. Therefore, it's the maximum count of entries we can handle by those system, master slaves system. And for sure, in order to go to this range, we should apply modulo operator here. And in case our hash mode is in range of particular minimum and maximum hash values for particular child, we return this child and we will use it for sending the request to it. Otherwise we should show exception, because this function anyway should return something. In case it doesn't return some value for our child, we cannot continue adding, because we don't know where to add the value for what partition. Okay, that's all. Now we should get this child, and in order to determine the child we should one additional values for parameters for the arguments. Now we should initialize our children list, because we have our URLs, we have partition items per partition, we have overall partitions, and now we can define our minimum and maximum hash value for each partition. We put here internal keyword because it should be tested by a separate test project, and the only way we can do that is just expose internal keyword and use some kind of attribute, but we will not do that. It's just for you to know why it is like that. What does this algorithm do? It iterates through each children URL, and since we have count of values per partition, what we basically need to do, we need to put in the first partition some range. In this algorithm we will got from 0 to 29. At the second iteration we got 30 to 59, and etc, 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 while we have new child URL. And we have range multiplier for that purpose. In the first child, in case our partition items count is equal to 30, we got range multiplier times partition items count is equal to 30 minus 1. It will be equal to 29, and as a min value we'll got maximum, which is 29, minus partition items count, which is 30. It will be equal to minus 1, we add 1 and we got 0. And it continue to split our ranges between the partitions and got our children back. And now, after we determine child by hash and we determine particular client, we also should encapsulate the behavior of sending this value to partition in some kind of client. Let me create this client. The responsibility of child client is just to send HTTP requests and got the response from child, or AK particular partition. It is a method for our monitoring endpoint on each partition.